Hello everyone, welcome back to my channel. In this video today, I'm gonna solve problem 199, binary tree right side view. And this is also a medium problem as well. So the problem is just simply that they are going to give you a binary tree and they ask you to return the node to the rightmost of a tree. So basically, they just say that you give you two examples. So this is the tree that you're gonna get, and if you're standing at the right of this tree, okay, let me write someone as standing at the right. So if you're standing at the right of a tree, what you can see is that you can only see the node 1, 3, and 4. So you're gonna return 1, 3, and 4 here. So similarly, with the second example, if you're standing to the right of a tree, what you can see is that you can see 1 and 3, but 4 and 5 as well, because there's no other node that is blocking the view of the person. So they can actually see the node 4 and 5 as well. So at a first glance, this one seems a little bit tricky. I mean, it seems very tricky because if you're trying to do a DFS, it's kind of very difficult. But actually, there is one tips that I will show you guys is that whenever you guys see something that asks about characteristics of a whole tree, like this is they ask you to see the side view of the whole tree. So basically, you're not going to think about DFS, but you guys have to think about the BFS instead. And this is also the key of a problem. So BFS is just, we can say that this one is level traversal. So basically, this is not going to use the recursion or stack or a queue to, I mean, they did use a queue, but they're not going to use a stack to actually traverse each node and then get backtracking and then go forward. That's one is not BFS. BFS is just simply they will iterate each level. So they will label this one as level 1, this thing here as level 2, this thing here as level 3. And you guys can already see the pattern. What we have to return is that we just have to return the node on the rightmost of a level. So basically we can assume that we have each level has a length of n. So we just have to return the element at the index n-1 of that level. And that's how we can solve this problem. It's very simple. Similar here as well. So if you guys are given a tree, you guys can do a level traversal. So they will give you a 4 level thing. So because this one size is 1, this one size is 2, this one size is 1, and this one size is 1. As I have mentioned the formula here, we just have to return the element at the index n-1. So from here, we just need to return 1, 3, 4, and 5, because this one is in the index 0. We are using in 0. This one return index 1, and this one we're going to return 4 and 5. So it's very simple. But the intuition that got to this one can be a little bit tricky, but it just requires you to know a BFS. It just requires you to have quite of a experience to work on this. And I will show you guys the code below. This is the code for that. So basically what you're gonna have is that you're gonna have a queue to hold the node at each level. So we have a queue here, and you push the first node to that. I'm gonna say that this one can be, you guys gotta see this pattern a lot when you guys learn about graph theory, learn about binary tree, because this is a BFS traversal. It's pretty similar in any type. So basically what we have to do is that we have to iterate for each level, right? We have to iterate each for the whole level, and if we reach to the size -1, which is the n-1, we can actually push that into the result value. Okay, so that's how we can implement this question. Alright, so the time complexity for this problem is also very easy to calculate. It's just O(n) because what we do is just traverse the whole binary tree once, and for the space complexity, it should be O W, with W would be the weight, the width of the binary tree. It's not really the width, but it's gonna be the biggest width of this binary tree. Okay, so this is how we can solve this problem. Thank you guys for watching my video. See you guys again in my other videos later.